Okay, so section 2.3, we're starting to now, there's three scenarios right now in which we don't have a rule for. That just off the top of my head, that we cannot take the derivative of. So I'm going to give you three problems, two of which we'll do today. So one scenario is if we have multiplication. So let's say we have e to the x times sine of x. A function of x times a function of x, we don't have a rule for. So we don't have a rule for multiplication of two separate functions. Okay? We don't have a rule for, so these will say no rule yet. So we have no rule for multiplication. We also have no rule for if it's x squared divided by, so let's say it's divided by cosine x, had it been x, then I could simplify, but if it's from a different family like this, where I cannot make the simplification, I have no rule yet. So I have no rule for multiplication of function, I have no rule for division of functions. Now, this is 2.3, what we're going to cover in here. Separate, which is down the road, which will be after your mid-chapter 2 test, we also have no rule for, and this is, if I have a function inside of a function, this will be section 2.4, but like say we have e to the 4x. We don't have a rule, well, actually I could manipulate this, but now we don't have a rule for this, okay? Because you have a function of x here, it needs to just be e to the x based on our rules, or we couldn't do y equals sine of x squared. So for all these, no rule, what I'm talking about, no differentiation rules, okay? So notice that all of our functions that we work with have to be functions of just the x. You cannot have a function inside of the function. It can't be like e to the 2x, e to the x squared. Those we cannot differentiate yet. So we're keeping our functions in the simplest form as possible. So e to the 4x or a sine of x squared, when you have a function inside of your function, then we'll address that in 2.4. So that's later, okay? So now we need two rules. What's the rule for multiplying and what's the rule for dividing? Now there's a derivation using limits, but again, just for keeping things simple, I'm just going to give you the rule. Now remember, we do have a rule for adding and subtracting. Now when you do add and subtract, you just take the derivative of each one, and it'd be f prime of x plus or minus g prime of x. So you just take each derivative separately and add and subtract. Multiplication and division doesn't work that way. Okay? And it comes, the reason it doesn't is because when you derive it using limits, it comes through in that proof. So I'm going to give you, we'll say, okay, we have f of x times g of x. So I'm going to give you the rule in two formats. I'm going to give it to you with f and with g, and then I'll give it with using different letters, and I'll explain why we do that. So here's the rule. F prime of x times g plus g prime of x times f. And that is what you have to do in order to get that differentiation. And it's just one of those that you have to memorize. Okay? So f prime g plus g prime f. Okay? And that is a rule. All right? This is called the product rule. For obvious reasons, it's because we have the product of functions. And then if you want the quotient rule. So f of x divided by g of x, it's f prime g minus g prime times f over g of x quantity squared. Now, because we're used to f and g's, we'll keep it like that for now. But if you look in the textbook or you look in other places, they don't use an f and a g in the formula. Okay, they use different letters, and it's just more of a keep it simple And this F and G is used all the time. So let's get some practice. So what we're going to do, we're going to apply these formulas to the 2.3 problems that we said we can't work yet. We're going to do each one of these using the proper rule. So now we have a rule. We can erase that, and we're going to work each one of these problems. So here's my suggestion to you. First thing I would do, so obviously I'm going to use, obviously this is the quotient rule here. Put that out by it. So here's our rule. So what is it? Well, what are they? There they are. There are two formulas to allow you to differentiate. So now how do we use it? So let's get to practice with that. Basically what I do is this. I recognize whether it's going to be product or quotient rule, and that's easy, whether it's a multiplication or a division. The next thing I do is I just make my name. I say, okay, I'm going to call that guy what? What would the label be for e to the x? F of x. Okay? I'm going to call that one f of x. I'm going to call sine of x what? G of x. Then I go to the side and I'll just do this. I'll just say f of x equals, put what it is, I'll find f prime of x equals g of x equals, and I'll find g prime of x. So now I'm finding every component that I need for the formula over here to the side. So I'll label f and g, I'll find f prime and g prime, and then from there it's a plug and crank. After that, I'll just drop down and plug this. So we know x squared cosine x is our other problem that we're going to work. So my next step would be this. So I've labeled f and g. I'm finding f prime and g prime over here. And then for practice, my recommendation to you is just write out the formula so that you get to start memorizing it. On these first two, we're going to use f's and g's, and then we're going to change the letters. We're not going to use f and g anymore, okay? So I'm going to try to recite it. It goes f prime times g plus g prime times f. Okay, try to kind of like get the saying down and memorize it. I mean, of course, it's of x. I'm just trying to save myself some writing. Okay. All right. And then once you do that one, so we'll just call this example 1 for 2.3. This is part A. Then I want you to do part B. Part B was x squared over cosine x, and we want you to find that one using the quotient rule. So take a second, see if you can apply the rule and get the answer for that. Okay, so it should be a 2 seconds, not very long to do this problem. So f of x is e to the x. Eli, what's f prime of x? All right, g of x is sine of x. Naomi, what's g prime? cosine x. And then from there, you just plug in, and we'll talk about simplifications that you could do, right? There might be some. So let's see, I'll plug in. So f prime is e to the x, g is sine x, plus g prime is cosine x, times f is e to the x. What's the only simplification you could do? Only way to change this answer. Yeah, factor e to the x out. That's it. So for me, it's not that necessary. Okay? All right, here you go, part B. So now again, we know it's quotient rule. So the top I'm going to call f, the bottom g. So I'm going to come to the side. If f is x squared, what's f prime? And if g is cosine x, what's g prime? And then I'll write my rule out so I can see that the rule should be f prime g, so f prime times g minus g prime times f, all over g squared. Okay? Okay. All right, so Ivan, what's the derivative of x squared? And the derivative of cosine x? Negative sine x. So a lot of this is just memorization, right? I'm going to give you the last four trig functions. We're going to get their derivatives today because you'll see it ties in with quotient rule. All right. So, all right. So we've got that. Now it's just a plug and crank from here. So let's see. So f prime, we should put what? You guys tell me. 2x. G is cosine minus g prime, which is, oh yeah, you're right, negative sine x, sorry, I was jumping the gun, times f, which is x squared. So that minus a negative, we would turn into a plus. If you want to factor in x out, you could, okay? And then g squared, so I know it means cosine x quantity squared, but we learned last year that a simpler way to write this without the parentheses is just say cosine squared x like this. Okay, you put the 2, the exponent between between the s and the x there, okay? And that means cosine squared. So the only thing I would change is maybe move this and make this a plus. And there's your answer, there's your derivative, okay? All right, now, I'm going to go ahead and redo these rules without f and g. So I'm going to go ahead and break you of it because I want you to go ahead and get used to what we normally use, okay? So we're just going to rewrite the rule. I'm just going to take f and g out and put different letters in, and I'll show you the letters that we use for that. So instead of saying f of x, we're going to use u and v. And they're both functions of x. Those are not constants. U is like a function of x, u of x. V is a function of x. Now notice they're lowercase, so u has a tail, and v, v is that shape. But make sure you put a little tail on u. So now I just go and replace. U took the place of f, v took the place of g, so if I rewrite this, it's going to be u prime v plus v prime u. And now you can see it's just less writing. Rather than writing f of x, you just say that u and v are functions of x, so we make that statement u and v are functions of x. So we go ahead and make that, and then we rewrite our formula. So same thing here, u divided by v, and then I'll rewrite my my formula. You don't need to erase in yours, just you can keep both. But now it's going to be u prime v minus v prime u all over v squared. So it's a more compressed way to write it. Less writing. Actually rolls off the tongue a little bit better, in my opinion. Okay? All right. Two more, so we'll call this example 2. Differentiate. So 2 more problems. All right. Part A, if g of t equals 3t squared minus 1 over 2t plus 5, find g prime of t. Now, another reason why we would want to use u's and v's and not f and g, because see, now look, g is the name of the whole function. So it would be confusing to come over here and call the bottom g. And notice this is of t. So I don't want us to always use x and get locked into x. Now, I want you to see that it is possible for your u and your v to be more than one term, right? So this, all of this is u, okay? The whole numerator, because it's a function. In this case, it's a function of t, not a function of x, but you get the idea. And this whole denominator is your v. So remember, what was my hint? My hint to you was to do what first when you have these problems? What's the first thing you should do? So the first thing I always do is I identify what my u and my v are, and I go to the side. U is 3t squared minus 1. V is 2t plus 5. So I first make that identification. Before it was f and g, not u and v. Then I drop below and I'm going to find what? U prime and v prime. I'm going to find those. And then the last step before I finish the problem is what? What am I going to write down here? So I identify u and v. I find u prime and v prime. There was one more thing I do. Write out the formula, okay? Because this needs to become a plug and crank, where you find all the components of the formula and you plug it into the formula. All right, so you're gonna say it with me. What is the quotient rule for u divided by v? It is 1, 2, 3. Ready, go. Prime v minus v prime u, just say u, all over v squared. Let's try it one more time, because if we were in choir class, we've got an F. Okay, we're going to try to go in unison. All right, ready? 1, 2, 3. U prime v minus v prime u all over v squared. There's your quotient rule. Then you write it out. If you follow this path, this little step. So first, our first step, identify u, v. Second step, find u prime, v prime. So you find each one of those separately. Third, write out the product or quotient rule, whichever one you need. Why do you think I want you to do that? I mean, you could just look at the picture, look at your notes and get the rule. Why do you think I want you to get in the habit of writing this rule out? Yeah, you're gonna memorize it faster. You'll memorize it faster if you do that, okay? All right. Okay, there you go. So finish this problem and then we'll do one more. F of x is square root of x times sine x. Find f prime of x. All right. These are the last two that I'm going to do with this in this basic form here, and then we'll move on. I'll give you the 4 derivative rules for your trig functions. So this one will require a little extra work, right? Because there's some more, so you'll need to simplify your answer. This is where it's gonna be a little bit more difficult now in matching, okay? All right, so let's at least check your U prime and V prime. All right, so Graham, what'd you get for U prime?
U prime is 60.
And V prime?
2.
2. Remember, on linear functions, it's just a slope, okay? That makes it easy. Then it's just a plug and crank. So let's see, so we've gone through the steps, we found U prime, V prime, I've written out the product or the quotient rule, which in this case is the quotient rule, then I plug everything in. So Graham, you tell me what to write.
Okay. 60 times 2t plus 5 minus 2 times 3t squared minus 1 all over 2t plus 5 1b squared.
All right, so really the only thing we need to do is what would you say do to the top, probably? Distribute and combine like terms, and then that should finish this off for us. So it looks like you get a 12t squared plus 30t minus 6t squared plus 2 all over 2t plus 5 quantity squared. So what happens is it looks like we can just combine the t squares and that's it. You could take a 2 out of everything if you wanted, but you should get 6t squared plus 30t plus 2 over 2t plus 5 quantity squared. You could factor a 2 out of the top, but it's just going to be sitting there anyways. So that should be your final answer. Now you can see we just bumped it up just a little bit. Now there's more algebra that's involved. Okay. Any questions about that? Eli, you got a question?
Why wouldn't you, like, you know how 2t plus 5 squared if you don't, like...
What do you think is going to look better? 2t plus 5 quantity squared or 4t squared plus 20t plus 25? It's whatever you think, right? I just think that's more of a compressed format, and it saves you work. So typically we don't square the bottom unless there's an advantage to it. Unless maybe I could end up canceling, but so it's typically not done. That's a good question. Okay. All right, do part B, and then we're gonna add the 4 trigonometric rules that you have, okay? And this is just part 1 of the lesson. This is probably a 3-part video that we will put together over the next couple of days. This is my door. Hang on. Sure. Okay. Help me with the steps real quick. What's our first step? Identify U and V, right? Second step, we'll go to the side and we'll find what? U prime and V prime. All right, now a little hint or a little shortcut. I would go ahead and memorize the derivative of square root of x. I would make it a rule. Because think about what we got to do with square root of x. We got to make it a 1/2. Then we got to move the 1 when we take the derivative. Then we got to move the 1/2 in front. Then we got to subtract 1. Then it becomes to the negative 1/2. Then we move it down, and then we put the square root. So what I'm going to do is this. I'm just going to write what it is up here. Let's see if you agree. What is the square root of x? The derivative of square root of x is 1/2 square root of x. And I get that from power rule. So rather than just doing power rule every time, it might be advantageous to go ahead and memorize this. Again, why is that? Because if we make it x to the 1/2, what happens? It's 1/2 x to the negative 1/2. Then that has to move down. So if this is y, here's our y prime, or I guess this is u, sorry. U and u prime, right? Then it becomes 1/2 x to the 1/2. And then x to the 1/2, make it back to square root of x. So 1/2 square root of x. So I would just memorize that derivative of square root of x is 1/2 square root of x. For adding rules, it might be helpful. All right, and then find your v prime and then plug and crank. And then I'm going to show you that what you think is the answer is not the answer. Probably not. Because there's going to be some simplifying involved. Oh, what's step 3? I didn't do step 3. What's step 3? Right, write it out. That's right. I say sing the song. Okay, so I'll go ahead and write the formula out. U prime v plus v prime u. Those are multiplications there. Of course, if v is sine x, v prime is cosine x. Then we'll sub everything in. And I think we'll look at how the WebAssign deals with this, but I think they'll ask you to simplify. So u prime, 1/2 square root of x times v, which is sine x, plus v prime cosine x times. So this might be fine. A lot of times now the problem is though you've got a fraction in here, they may want us to get a common denominator. I don't know. So I'm just letting you know, I mean, yeah, that's the derivative, but it may say, you know, can we get a common denominator and make it one fraction? Because technically we have sine over 2 square root of x plus cosine x times square root of x. Well, then I would need to multiply this by, then I would need to multiply this by 2 square root of x, 2 square root of x, and then I could make it one fraction. I don't know if they would, if they're gonna ask us that. So then, if I did that, this right here would turn into what? What's square root of x times 2 square root of x? Running out of room. What's square root of x times square root of x, guys? X. X is, the square roots cancel, you get x, so that's 2x. So the answer, you know, you say, well, what would my final answer look like? Well, it would be, the numerator would be sine x plus 2x cosine x. I would put that 2x in front of the cosine x over 2 square root of x. So this answer and this answer are equivalent. It's just now I've simplified into one fraction. So we'll have to see how the homework could be finicky and how it wants our answers, okay? So I'm going to add our rules over here. So just to get them out of the way. So we've got our product rule, u times v, u prime v plus v prime u. We've got our quotient rule, u over v, u prime v minus v prime u all over v squared. And then we've got our derivative of square root of x, which is 1/2 square root of x, okay? And we already know what the sum and difference of functions is. Now, we have 4 rules left that we're going to do, and now it's just collecting them and memorizing, okay? So we are going to make a rule for each of the 4 remaining trig functions, and you'll see why we can do those now. So for instance, we're going to make a rule for tangent. We're going to make a rule for cotangent. We're going to make a rule for secant. And we're going to make a rule for cosecant. Now, what we're going to do, we're going to derive them and see what each of these are equal, and then that'll just have to add to our memorization bank, or I would start to make a cheat sheet with all my derivative rules on that one sheet. Okay, so start adding them. Now you're gonna see, now we're adding on to our list, okay? So tangent, so let me just call it y equals tangent. Let's just say, look, if we can find y prime, then we then have a rule for tangent. And instead of working this out every time, I'm just gonna memorize what it equals. Problem is, I have to base everything on previous knowledge. In order to make something new, I've got to use old information to help me make a new rule. Does that kind of make sense what I'm saying there? So, how am I going to do this? Because I don't know the rule for tangent. So, I need to find the derivative of tangent, but I don't have a rule for the derivative of tangent. Now, this is where you have to dig deep on why trigonometry is so important in calculus. What is tangent equivalent to in trig? It is a division of two functions. It is in your trig notes that you would have done at some point, probably chapter 4-ish or something. It is sine x over cosine x. So I would memorize that tangent is sine over cosine. That's just a rule, okay, in trigonometry. Well, why is that important to know? Well, now, instead of me doing y equals tangent, I'm going to do y equals sine over cosine, and I'm going to find the derivative of this function. Now, can I do the derivative of sine of x divided by cosine x? First of all, it's a fraction, so do we have a quotient rule for this? Yeah, we have a fraction rule, right? And second, can you do the derivative of sine and the derivative of cosine separately? So go ahead, go through the steps and see what the derivative of sine over cosine is. And that is giving you the idea of how we would derive all four of those, okay? So see if you can go through the steps, and then we'll just save that answer. I know why you're not familiar with those is because you know when we did those? I did them. They're on YouTube. You were gone. So all those lessons were done via YouTube and sent to you. So I'll send you the lesson on the derivation of those. Okay, so let's look at this. So first step, identify your u and your v. So sine x is u, cosine x is v. So if u is sine x, v is cosine x, then I'll drop down. What's u prime and v prime? U prime is what? Cosine x, and then And then V prime is what? Negative sign. Very good. All right, then it's just plug and crank. So what do we get? Oh, so it's U prime V minus V prime U all over V squared, right? And so then we plug in. So U prime cosine, V cosine minus V prime negative sine times U sine all over cosine squared X. Again, this is where the identities come in and help. Cosine times cosine, we say, is cosine squared. Minus a negative is plus sine squared. All over cosine squared. Okay? Well, this is an identity. This is a Pythagorean identity from trigonometry. And I'll send that video out where I derived all these identities, or got you all these identities in pre-cal actually. Cosine squared plus sine squared equals 1. So that whole thing up there is just 1. Okay? You can see, I'm trying to see what is the derivative of tangent in its most simplified form, and I'm just going to memorize it, because nobody wants to do this every time. We're just trying to find something we can memorize. All right, so let's look at all the rules I've used. So tangent is sine divided by cosine. We use that. We also use this cosine squared plus sine squared equals to 1. That's a Pythagorean identity. And the last rule I'm going to use is that 1 over cosine is secant. That's a rule. We would have done that one, I think, maybe before you left. I hope. I feel like we did. So if 1 over cosine is secant, then 1 over cosine squared is secant squared, and there's the derivation for tangent. The tangent is secant squared x. So you can see there is a method to derive all 4 of these. You just have to convert it to what it is equivalent to, and then go from there. So what I'm going to do is I'm just going to write what the other 4 are, or the other 3 are, and it's just a memorization now. So cotangent is negative cosecant squared x. Secant is secant x times tangent x. And derivative of cosecant is negative cosecant x times cotangent x. And those are the 4 differentiation rules for the remaining trig functions. And now it's just a substitution. So this is the derivation for one of them. Obviously, we could derive more if we wanted. So we'll just call this example 3. Find the derivative. Part A, y equals 7 cosecant t plus tangent of t. And B, f of theta equals a cotangent of theta. Okay. So see if you can use the rules to take the derivative of each of these, and you're just substituting. Now I changed the variables to t and theta so you know that you apply the same rules. So there's no, so first question, do you see any product or quotient rules on the board? Is there any product or quotient rule? A constant times a function, do you have to do product rule? No, you got a rule for that. It's just 7 times whatever the answer is. Okay? So you got to see what's the derivative of cosecant, what's the derivative of tangent, and what's the derivative of cotangent, but use those variables that I've given you. Don't use x. I wanted to change the variable so you go ahead and are familiar with that. let's see. It's just about knowing the rule. So, derivative of 7 cosecant t plus tangent t. Well, the derivative of cosecant is negative cosecant x times cotangent x, but in this case, I'm using t. So it'd be negative 7 cosecant t cotangent t plus the derivative of tangent t. Well, the derivative of tangent x is secant squared x, so the derivative of tangent t is secant squared of t. So does everybody see how I applied the formulas to that? Okay? All right, there's that answer. All right, derivative of 8 cotangent. Well, 8 times, so what's the derivative of cotangent? Well, when I come over here, it's negative cosecant squared, whatever your variable is. So it's going to be 8 times negative cosecant squared of theta. You don't have to put parentheses around the theta there. But I'm not going to say 8 times negative, I'm going to say negative 8 cosecant squared. Okay? So just be ready that your variable may not be an x, it could be a t or a theta, and you still use the formula accordingly. Okay? Just change the variable. All right? So, how many of you are putting all of your rules on one sheet of paper? Yeah, that's what I would do. Find a separate one sheet, put every derivative rule on there. That way you go into one place. Okay? All right, we're going to stop there. That'll get you going in 2-3, okay? That's part 1.